Bismillahirrahmanirrahim. Welcome to the third lecture of discrete mathematics and its application. So the topic is function. What is function? So today we will talk about the function. So what is function? Let we have the graphical representations of a function. So function can be represented graphically in several ways. So the first one like a Venn diagram, E to A to B, C to D, and so on. Maybe like a graph, maybe like a plot. So this is the method of representation of a function through graphically. So now coming to the function, not a function example. So these are not a function. Why? You can see 1 2 3 alpha, beta, and gamma. Okay, A to alpha is a unique, 2 to beta is unique, but this is remaining, which is not used. So when there some number is there and there is not used in a function, so it's called it's not a function. Just like I will show you later on. And another one, 1 for A is unique, 2 is for a D is unique, but 3 is not unique now. 3 also is signed for a B, 3 also is signed for a C. So it's not a function, because in a definition we say that A, so every number will be unique for another number. So keep in mind that. So this is not a function example. So some function terminology, that function f A to B. So it means f A to B, this called A belongs to A, B belongs to B. Then so now the keep in mind, inside a function this value A is the domain of a function, B is the codomain of a function. We also call it a range. We also call it range of a function. We can also, B is the image of A. B is the image of A. Like you, whenever you are standing in the front of a mirror, so you will see the your image inside the array. It means B is the image of A under function of this. Or we can also say A is a pre-image of a B under F. So just like example, so the most important is domain and range. You need to remember that what is domain and what is range. So in a note you can also keep in mind, and later on you will see that B may have more than one pre-image. So we will see later on, because we have some properties of a function. So in function you will see that. So keep in mind about domain and so now see in this example, A is a pre-image, B is the image, but under the function of A. So you can also see that A is the domain and B is a codomain, or we can also write that range. So we also write that range. So if you keep function A to B, so what does it mean function A to B? You know about that because you studied it in your early classes. It means that you will be putting the values of A, which is stored from plus minus 0 1 plus 1 minus 1 minus 2 and so on. So it means like a number of value you can put in the value and that will show you the output. So this is called, so when you are putting these, this is called domain and the output will be the range. So this is the basic example of a function. So now you can see the visualization. So this is your domain and this is your codomain or your range. So it means all these values in a domain will belongs to B. All these values belongs to B. So you will see the image. This is the image. So this is just like visualizing how you can represent the function in terms of a image. So again, I told you before the range and domain. So these two terms are very important for you guys. So you need to be keep in mind. So So now coming to the function addition and multiplication. So let f1 and f2 be a function from a to r. What does it mean, a to r? R mean is a real number. So a will belongs to a real number, and then f1 plus f2 and f1 multiply with f2 are also function from a to r. Again, when you are putting a real number in a function, the result will be the real function, and defined like x belongs to a by, so this is the way of addition. How you can also be add like this, you can also be add like this, it's the same. And you can also multiply like this, you can also multiply like this. This is your example now. f1 is equal to x power 4 plus 2x square plus 1, and f2x is equal to 2 minus x square. Simple. You can add it, f1 plus f2x like this, you can be add like this, both are the same way. So this is your f1 and this is your f2, and your result is x4 plus x2 plus 3. Just simple addition. Nothing is confusing. Now multiplication. So the same way of multiplication. So the result will be this one. So this is the method of addition and multiplication of a function. Nothing is confusing here, so kindly don't confuse yourself. So now it's your task. f1 is equal to 2x, f2 is equal to x square. Find f1 plus f2 and f1 multiply with f2. Simple. I already solved one and already solved. Just simple things, just simple addition. Function is so easy topic, so keep it interesting. So now coming to the types of function. This is a types of function. So types of function is, the first one is one-to-one function. By name is noun, one-to-one, one-to-one, one-to-one. Hope you got it. It means a function is one-to-one if each element in the codomain has a unique pre-image. A same thing like B will have a only. So this was your domain, this is your codomain. So your codomain will have a pre-image. Also can be defined like a function f from a to b is called a one-to-one function f whenever f of a, f of b, then a will equal to b. It means a will have a unique image for a b. So no element of a b is the image of more than one element in the a. Also can be defined in a one-to-one function. Given any y, there is only one x. It means for a y there will be only x that can be paired with the given y. We will see later on in example, so you will be understand it better. A function, now keep in mind, a function is said to be injective if it is one-to-one function. So we have a one-to-one function which have a one-to-one image, unique image. So now coming to the example of one-to-one function. So hope you will be better understand now. A function is one-to-one if no more than one element in the domain is paired. What's paired? Like a couple with an element. Like just see, A for a A, B for a B, C for a C. So it means C is for a C, but C will not for a B. If it is like this, it's not be a one-to-one function. So always be unique pair, unique pair, unique pair, unique pair. Just like one man and one with a one girl, like husband and wife, just one, not one husband with the two wife. If it's like one husband with the two wife, not to be one-to-one function. One husband with the one wife, it's like a one-to-one function. So now you see the examples, which one is the one-to-one, which is not the one-to-one. So let's see this one. A for a 1, this is for unique, this is for unique, and this is for unique. So it means this is one-to-one. But now coming to this one, this is unique, this is unique, okay, but this is not unique. Again, this is used for a 2 values, so and the 2 is not unique for, so that's mean that's not a unique one-to-one function. Hope you will be understand it. So another example, you can see this is one-to-one function. Each and every is unique for, if someone is not used, it's okay. And for one-to-one function, keep in mind, if one of the element is not used, it's okay, it's fine. But now again, this one, this and this is used for a 2, so it's not a one-to-one function again. So hope these two examples will be works for you. Example of one-to-one function, like we have a different function for a x cube function. If x is equal to 1, so your result will be 1. If you have x is equal to minus 1, so your result will be minus 1. So if you can see, your range or your codomain is different from each other. It means for a 1 it was 1, for a minus 1 it was minus 1, and maybe like for a 2 it will be 8, for a 3 it will be, so it means that each single input have a different value. So this is called one-to-one function. If you can see this example, so maybe up to some, let's see, let's just, for example, let's just consider if x is equal to 1 and x is equal to 2, just example it, maybe up to one point it maybe will be same. For x is equal to 1, for x is equal to, so f of 1, let's just make it example just for thinking, just like function of 1 will be equal to 2, function of a 2 will be equal to 2. So now what does it mean? That 1 is also 2 and 2 is also 2. So in this case, this is not a one-to-one function. So that's why maybe up to some point it will be this, give the same value of a 5, maybe it will be not. All odd function maybe. So hope you will understand it, what kind of a function will be one-to-one function. So in this example 1, example 2, example 3 and 4, all these are one-to-one functions. So now we will see which kind of function will not be one-to-one. So now you can see this example. This is called, if you have f of x is your minus 1 and x is for a 1. So absolute sign, this is called absolute sign. Absolute sign always make a negative value to be positive. So if you can see minus 1 in absolute sign, the result will be 1. And you can see if you can have a 1 value, it also again 1. So it means minus 1 and 1, they are giving the same value. So it means this is not a one-to-one function. Again this one, if you have plus 1 and if you have minus 1, so for both it give you 1. So again it will be not be a one-to-one function, and so on. So hope you got the aim of one-to-one function. So your task is in a graph way. Let's come to this point. This graph is coming from here to here. So when your x value is 2, maybe your graph will be this one, and your x value is 2, your graph will be this one. So it means on a single point it give you same value. So let's see this one. If you have a g of x, so if g of x is equal to y, let's see this, I'm telling you that g of x is equal to y, so y is equal to x minus 2. So if you are putting value for x, so x is equal to 4. Let's see, if x is equal to 4, so your y will be equal to 4 minus 2 in absolute sign, your result is 2. Okay, but if you are putting x is equal to 0, so again y will be the same, because 0 minus 2 will be minus 2 and absolute sign will make it positive. So again you will see that for a different x values, for a different x value, the range is the same, or the codomain is the same. So it means this is not a one-to-one function. Hope it will be understandable for you. Again the same one, if you have a 2 value, for a 2 this one, for a 4 this value, for a 0 again this value. So it means when you are putting 0, when you are putting 2, when you are putting 4 in this function, the output is 2. So this is not a one-to-one function. So now coming to the another type, onto function. So in the onto function, just keep in mind that if each element in the codomain, it means each element in the range is an image of a pre-image. Let's see, you have a 3 number in a, so you must have 3 another number in a b, maybe 4, 5 and 6. So it means this one is this one and this one. So each and every element will be used for another number, so it will make a pair. So again you can see here a function f of b is subjective if the image of f equal its range. What does it mean? Range, it's the same, it's the same. Again it's come to the another one, it will be more clear. A function f from a to b is called onto f for all b. In a b there is an a in a such that f of a in b, so all element in a b are used. So a function is said to be subjective if it is onto function. So keep in mind this one. So in example you will better understand what is onto function. So if you see the example, so a, this one, a is for this for, so if you see this value is just for a 2, so for in onto function it possible, but for one function it's not possible. But if you see all the element of a b is used in a all element of a. So what is the difference between both? That one element of a codomain can be the output of a multiple domain. So if you can see this one, so there 2 element is not used, so this is not one onto function. So it means in onto function every element need to be used, so that will be the onto function. So this is another example, you better will understand. All the member are used, this onto, all the member are not used, that will not be a onto function. So now coming to the example of onto function. So this is your onto function, which is, but for what? For z to z, for integer. Integer mean including plus minus values. Plus minus value will include, so it means this function will be onto function. And also this can be onto function. How? If you can put x is equal to 1, what? If x is equal to 1, so 3 minus 4, so f of x will be, and we can call f of x is equal to y, so your result will be 3 minus 4 is 1. So for a 1 it will be 1. So for a 2, if you can put it 2, so 3 2s are 6, 6 minus 4, 6 minus 4 is 2. So again if you put 3, so 3 is the 9, 9 minus 4, so 9 minus 4 is 5, so and so on. So it are using, so it means as you progress along the line, every possible y value is used, every possible value. If you can put 0, if you can put 1, 2, 3 plus 1 plus 2 plus 3 and so on. So every y value, it mean what kind of y values? It mean like this, it will start from 0, 1, 2, 3, every value is going to be used if you are putting the different x values. So this is called onto function, every values will be used. So now this function x cube, it will be onto ones, you are putting all the real number, x will all be real number, so that will be onto function. When you are putting the values for real 0, 1, 2, 3, 4, so all the y values like 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, each and every single number will be used. It not be like that you are using 5, then 3, 4, 2 are missing, then you will use minus 1, not be like that. It mean onto function mean that 5 will be used, 4 will be used, 3 will be used, 2, 1, 0, minus 1 and so on. This is the example of onto function. So now coming to example of not onto function. So what does it mean? If you have g of x with 2 x squared and all real number, all real number mean when you are putting -1, just when you are putting 1, so your result will be 1, but when you are putting 2, your result is 4, for a 3 your result is 9. So it means in a y-axis there is a missing of a number, like see -9, then 4, then 2, so other number are missing, so that's called not onto function. Again you can see if you have x is equal to 1, so result will be 2, 4, 5 again missing, 2n plus 3, but for integers this function will not be onto, this one for also not onto. So this example of not onto function. What does it mean? They are missing the numbers. When missing a number, it means it's not a function. But when there is not a missing a number, but it's continuously used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 or -1, -2, -3, -4 up to like continuously. So that will be onto function, otherwise not onto function. So another example, you are told like this is x square minus 2, like a parabolic function, and g all for a real number. So this function not onto function values less than -2 on the y-axis are never used. What does it mean? If you are using x is equal to 0, so your output will be -2. So up to -2 it's fine, but when you are putting 1, so 1 minus 2, it will be -1. If you are putting 2, so 4 minus 2, it will be 2. If you are putting 3, so 9 minus 2 is 7. So again it's missing a number. When they are missing a number, so it means that it's not a onto function. So it's a task, so you can try it by yourself, but for all real number keep in mind. So now coming to the another type, bijective function. So what is bijective function? So those functions can be both one-to-one and onto. A function which can be one-to-one or onto function, that's called bijective function. Or a function f is a one-to-one corresponding or a bijection or reversible or invertible. F it is both one-to-one and onto function, and you know about one-to-one and onto function. So hope you can easily get the bijective function concept. So now this example, this is both one-to-one and onto function because each and every value have a unique and all the values are usable. So all the y values are usable. So it is called both one-to-one and onto function. That's called bijection. If you can see this, that all the values are not used. This is the first one, and also the two values used for the two codomains. So again, it's not a one-to-one. It's not a one-to-one. It's also not a onto function. If this value 4 was used for someone, but there is an issue because we told you for one-to-one that this number or this image will be unique. So that's why this is not a bijection function. So this is another example. This is both OnetoOne, so that's called bijection. This is not a bijection. So now this is the example of a bijection function. So this is a example of bijection 2x minus 3. If you putting the different values of x in the function, so you will have a one-to-one function and as well as onto function. Again the same, if you can put the values of x, so it will be one-to-one, it will be onto, again the same one. So this is not a bijection function again. So if you are putting the value of x, so all the values will be positive, so there will be no negative number, and also it's going to jump 1, 4, then 9, because when you are putting x value 1, 2, 3, 4, 5, so it will be jump and the y value is not be used. It will not be a onto function. It will be a 1, 1, but it will not be a onto, so that's called, it's not a bijection function. So now coming to the inverse of a function. So what is inverse of function? Just like you have a f of x, so it means what will be the inverse? 1 divided by f of x. This is inverse, or you can also be write like f inverse of x. This is inverse. So simple is how you can find the inverse of function. Change xy by yx. So you can see an example, you will better understand. So this is example. This is a normal value, x values and y value, which is minus 2, 0, 4, 7, 0, 4, minus 5 and 10. So now the inverse of function, so x and y will going to be interchanged. So the value of y will be the x and value of x will be the y, so and so on, the same value. So this is the example of inverse. So we will see an example again in a proof how we can be defined. So in this symbol you can see like this was x values, this is was y value. So inverse of this function will be opposite, so just rotate it by 180 angle. So now this value is x now and this value is y, so this is called inverse function. So it's like the domain of this will be the range for an inverse, and the range of this will be the domain for the inverse. So how to find an inverse function? Simply, let's see, this is your example. So you need to be find the inverse of y. So switch y by x and x by y. So x and this will be y. So you need to find a y from this equation. So 4 will become here, so this is 2y, y will be here, so this is your inverse now. So y is equal to 2x minus 4 was your original, so and this is your inverse now. Inverse will be equal to this one. Just simply switch x by y and y by x. This is simple method of finding inverse of a function. So now you can see another example like y is equal to x divided by 5x minus 3. You need to find the inverse of this function, that we can call it f of x. So the inverse of function like switch y by x and x by y. So this will be x now, this will be y, this will be y. So now it will become here cross multiplication. So your y is equal to x 5y3. So you need to find y, so take it y from this equation now. So multiply with x with this one, this is the y, and this is the y, so need to be combined. So these two will be combined, take a common of a y, so it's a common. 5x minus 1 will be here, so y will be here, so divide by 3. So this is your inverse. Now this is your inverse. Why we are doing to take a y? Because we need a y in a single form, so no need to lift your example in this form, because you need to take out the y. So that's why take the y and lift the x in a single form. So this is your example. This was your original y, and this is your inverse now, which is going to be changed. And it's a simple method, but just keep in mind whenever you are exchanging or you are switching x by y or y by x, so at the end you need to be take y in a separate in one side of the equality, and take x in the another side of the equality. So that will be works for you. So now coming to the another example, this is your function. You need to find the inverse of the function. So f of x is equal to this one, so you can f of x, you can be said that it's your y. So replace x by y and y by x. So then you need to be take a y from the equations. So in the so it will be 16x equal to, so take it 5 on both sides, so it will be, hope you guys know about that, how you can find this kind of example. If you have a 5 here, so how you can be, you can take a square. When you are taking a square of this one from here, like you can be solve this example. Like you have 5, so how you can take a square, you can take a root of 5 on a both side. So root of 5 mean y5 will be, it will be like 1 by 5. It's a root of 5. If it's root of 6, you need to write 6 here. If 7, 8, and so on. So it's a simple way of finding a inverse of a function. So now coming to the another example. So this is the another example of a cubic x cube like. So this is your while. So now this is your function. So replace y by x and x by y. So 4 will be here now. So this is your, so now it's a cube, so you need the cubic root on a both side, which will be this one, and this is your answer. Now this is your inverse of a function. So it's very easy method of finding an inverse, so it will help you. So now you can be find the graph of a function, because you have a different function. You have a straight line function, you have a square function, you have a cubic function, and so on. You have a compound function. So for all function you can find the graph. So this is like you have a y is equal to x square, which is a parabolic function. When you are putting a different value in the x, so when you are putting a different value of x is equal to 0, x is equal to 1, x is equal to minus 1, x is equal to 2, x is equal to minus 2, and so on. So you will get this kind of a graph. So this is the graph of a function. So you can be have a one another function like x cube function. Maybe you have a like compound function. You have like x square plus 2x plus 1. So every function have their unique graph. So just how you can find the graph, just putting the values of x and you will have the value of y. So then get the value. So let's see, you have x is equal to 1, so y will be 1, so this is your 1 point. When x is equal to 0, y will be 0, this is your another point. So if you have x is equal to minus 1, so your y value will be 1. So now you can connect all the points. So when you have a 2, your value will be 4. When you have minus 2, it will be 4. So combine all the points, so it will be your graph. If you have some kind of this graph, let's see just example in one kind of another function. You have a point here, you have a point here, you have a point here, then here. So how you can we get, like, combine all the point, it will be your graph of a function. Hope it will work for you. So this is another a floor function. So in a floor function we have a two, so largest integer. So in the largest integer can be represented by this one. So you can see the floor function is assigned to the real number x, the largest integer that is less than or equal to x. The value of the floor function x is denoted by this one. So you can see in an example, so you will be understand it better. So now this is, so floor function, the largest integer, so integer will always be greater than x. What does it mean? Let's see you have a, so let's say you have a function f of x, so f of x, and your x value is like 2.3. so this x will always be, we are saying that the integer will always be greater than x. It's to 2.3, so we can say that it will be 2. So 2, 0.50 minus 3.5, maybe minus 4. So we can be write the floor function in terms of this. So it will, for what does it mean now? Just simply, so 2.3, so 2 is near for a 2.3, so 2 is 2, 0.5, so it can be 1, it can be 0. So minus 3.5, it can be minus 4, near 4, so near to value. So this is called floor function, the largest integer. Just keep in mind the largest integer. So now the another is the ceiling function. The ceiling function, the value will be used a smallest integer. So simply smallest integer. So in example now you can see like x, so 2.3, so smallest integer it will be 3, 2 is 2, 0.5 will be 4. So now what will be, we are using the smallest integer which is greater than or equal to x. Hope you got the point. So these are some properties of a floor and ceiling function. So hope you guys can understand it by yourself. So your task is find these value. So 1.1 which is equal to 1, 1.1 which is 2, 0 minus 0.1 is minus 1. So you just define which one is the ceiling function and which one is the which one floor function. So all these have the values for that. So now coming to the composition of a function. What is composition of function? Composition of a, so this is just a notation for a composite function. Can be write like that, can be write like before I write. So it's just a notation, doesn't matter how you are going to be write. So now coming to the example of composite function. Let's see, we have a function f of x which is equal to 2x plus 3, and we have a function g of x which is equal to 3x plus 2. So you guys need to find f of g x which is unknown. So first of all, what are you going to do? We have basically a function f of x, so it means this value is replaced by x. So now it's very simple now. So you have function f, so where you have a x, just write g of x. Where you have a x, just write g of x. So g of x plus 3. So this is your simple now, because 3 doesn't have x, so we just write the, so now simplify. So 2, what is g of x? 3x plus 2, so plus 3 will be on the same position. So now multiply 3 to 6x plus 4 plus 3, and you will have a 6x plus 7. So this is your f and g of x. So this is a simple method how you can find a composite function. If you can put like x is equal to 1, if you can put x is equal to 1, so your f of g will be equal to 6 multiplied by 6, 1, 6, so it means your value will be 13. So f of gx will be 13 for value of 1. So you can be also simplify by this as well, that g of f of x. So simple, g will be here, where you have a x you can write f of x. So this is your 3, this is your f of x plus 2, so simply 3, so f of x 2x plus 3 plus 2, so just multiply 6x plus 9 plus 2, so 6x plus 11. So this is your g of x. It's a simple method to find a composite function. Hope it will be help you. So this is a simple method you can find. So we have another example as well, so you can try it by yourself. So if you see the example the same here as well, so it's just like confusing, so just follow the step as I did it, that will help you too. So this is another example, like f of x is this one, g of x is this one, so you need to find f of gx. So a simple method as we did it before, so no need to be confused yourself, it's just a simple method. So you're taught your g of x is this one, find g on minus 3. It's a simple one, just put x is equal to minus 3, and so you will get the answer. This is a simple method. This is your function, this is your equation, put the value of x and you can find that. So again your task, g of x is equal to this one, so you need to find the value of a function at a 0.5, so just put the value 5 and you will get the answer. And again another task for you guys, just f of x, g of x, find f of gx as you did it before, so simple. So where you have a x, so what you are going to point out to the simple one. Hope you will get it. Yes, this is the answer. This is simple, this is more simple. So now coming to the composition of function, just like inverse, if you have a function f of x and you also have the inverse of the same function, so this is the same like, so result will be the x. If you can find it out, that result will be the x. So the composition of a function and its inverse is the identity function. So ix is equal to x, so simple one, just keep in mind. So now we have another function, factorial function. So you know about the factorial, like what does mean by factorial? If you have a 3, so it means you can reduce 3 multiply 2 multiply 1, like what does, if you have a 3 factorial, so 3 factorial mean 3 multiply 2 multiply 1, so this is your factorial. Also you can write 0, but when you are writing a 0, so you need to write a 0 factorial, and 0 factorial is always is equal to 1. So this is a simple method of factorial, and this is the example. If you can see here, this all is the example of factorial. So hope this is work for you. So now we have exercise, question and answer, and each and single question is solved, so do it by yourself. Exercise, question is there, solution is there, question is here, solution is here, is another question and question again, and all these questions we did it, and so you can know about the function. This is another question and the solution is there. So question is here, solution is there, question, solution, and so hope you guys can be do it by yourself and you will have a good time. And this is just for your practice, so you know about practice make a man perfect. So perfect, if you want a perfect in a mathematics, do your practicing. Once you are doing your practicing, you will have a good time, you will have a good player in a mathematics. Mathematics just like a game. How many times you are going to do a practice, you can know about each and single point. When you are going to do a game, so how much you are doing a practice on a game, so you can be easily project, you can easily judge the game where you want to do what you want to do at each moment. So this is all for your practice. So hope you guys will find it good for your practicing. So thank you for your time. Hope this slides and this lecture will help you in the future. So anybody have any kind of a question, so you guys can ask, and I'm willing to answer you.